Okay, example 2, graph the set of x as an integer such that absolute value of x plus 2 is greater than 4. Notice there is no equals to here, it's an integers thing again, so it kind of falls into the category of what I was dealing with in the very last problem. I don't know why they didn't put the set brackets on it, but or braces, whatever, but there you go. I'll put set braces on it. So it's the same kind of problem the last problem was. So we have this expression here. That's our absolute value of inequality that we want to solve. So if I just take that out of the expression, it's going to be x plus 2, absolute value is greater than 4. Again, the absolute value bars are there. I can't just say, I don't like absolute value bars, go away. I can't do that. I have to legally get rid of them. And this is the second scenario, the one where it's greater than a positive number. And the way you deal with greater than a positive is, first you write down exactly what you want to write down. You get that idea of I don't like absolute value bars in your head, and just write down what you see without the absolute value bars. But then you got to write the word or, and then you have to write the same expression, which is x plus 2. You have to flip the inequality around, and you have to change the sign. Okay? If we know why, maybe that makes sense. Well, let me figure this out. If it's less than negative 4, if I'm here, which direction do I go?
That way.
That way, right? Go left, right? What do absolute value bars do? Makes things positive, right? We want this expression, which is absolute value of x plus 2, to be greater than 4. If I start here and go this way, I'm going to get these numbers here, right? If I make negative 5 positive, how big is it?
5.
Bigger than 4, right? And if I make negative 6 positive, it's bigger than 4, negative 7 positive, bigger than 4, negative 8 positive, bigger than 4. So, by saying that x plus 2 could be less than negative 4, that's the other criteria, because again, obviously all these numbers already are greater than 4, right? They're already positive. These are negative. They wouldn't be greater than 4, but the absolute value bars make them become positive, so they become greater than 4. So you create both inequalities to represent the two scenarios that can make this true. Neither one of these is solved currently because they both have x plus 2, so I have to move the 2 to the other side. That's going to give me x is greater than 2. Move the 2 to the other side. That's going to give me x is less than negative 6. And now, or is in the middle. Now I have to graph both inequalities on the same number line over the set of integers. So I got my set of integers, and let me start with x is greater than 2. Is 2 greater than 2?
No.
No. What's the first integer greater than 2?
3.
3. So I'm going to start at 3 with a closed circle. I'm going to go with 4 because it's also greater than 2 with a closed circle. Then I'm going to shade the arrow to represent that it goes on forever to infinity in that manner. If I'm graphing x is less than negative 6, is negative 6 less than negative 6? No. Is negative 7?
Yep.
Yes. And that's the first integer that's true, so I'm going to put a closed circle at negative 7, a closed circle at negative 8, and I'm going to shade the arrow to represent that it goes on forever. Some of you are still putting open circles on these problems. You see greater than, less than, there's no equals to, just everything's an open circle. Open circle, open circle, open circle. Okay. Closed circle because they're true answers. Open circle for the end point of a boundary, not including that number. So if it was real numbers, open circle here, shade this way. If it was real numbers, all right? Because we don't want to include 2, but we want to get really, really close to it. Integers don't have that problem. The very first integer that's true is 3. Then go that way. The very first integer that's true is negative 7. Then go this way. So you want to graph it in that manner.